There's always some level of doubt and uncertainty when it comes to vintage machines. And the even more important question in the first place: what happens on power up? Will it run or will it explode? Retrocomputing is the use of older computer hardware and software in modern times. I'm the vintage collector and these are my stories. When I turned on the 5150 the first time, nothing happened, which led me to believe I have a faulty power supply. Today, I'm gonna inspect the 5150 step by step to see if I can nail it down. For this, I have just the minimum configuration in front of me. The power supply with the mainboard and the speaker attached. Let's flip the switch. Whoops! Whoops? Exactly. It looks like it blew one of the tantalum capacitors. It's actually not uncommon for this to happen, still it caught me unexpectedly. For me, it seems unlikely to be a faulty power supply after all. I guess the reason it didn't blow during my initial test was because the machine was fully equipped at the time. As things are right now, I obviously need to replace the broken tantalum capacitor. I'm about to replace all capacitors. This will take some time, but is well worth the effort. And then I'm ready for a second shot. Will it blow again? As opposed to last time, where it literally exploded, this is a huge step ahead. I will now add the graphics card and connect the CRT. Let's see how this turns out. For my earlier test run, I had disabled the dip switch number 5 for the CGA adapter to be turned off. Now with the CGA board back in, I have to revert switch number 5 to the on position. Yes, this machine does not feature a text interface for the BIOS yet. You still have to configure things using switches. And here comes the CRT heavyweight. Awesome! No errorness beeps after all. I still have the vertical scrolling on the CRT, but at least I get the cursor to display. Also some error codes are shown, which I need to check out afterwards. But let's do something about the vertical scrolling first. I've been reading the user's manual. Yes, reading a user's manual. That's the thing nobody ever reads. This CRT type has 2 adjustment wheels on the backside for the sync settings. Let's see if this makes the trick if I adjust the vertical hold setting. Oh yes it does. Look at this. It's beautiful. The computer has started up and loaded BASIC from ROM. How awesome is that? And now, with a stable display as well, it's absolutely gorgeous. Now it's time to try out if my self-made diagnostic tape works. So I have here the Tandy Radio Shack CCR-81 that was already seen in my last video. I'm about to connect it to the 5150. And here comes the reality check. The cable I have is not the correct one. Comparing the pinout, the IBM PC has a DIN 5 connector, whereas my cable sports a 7-pin connector. By comparing the technical documentation, I realized that the pinout is totally different, so it's really not an option to clip off the excess pins. In the meantime, I can fabricate something temporary and do some ad hoc wiring to see if it can go working. As you see here, I use breadboard patch wires to temporarily hook up my audio cables to the DIN connector. Not the most beautiful thing in the world, but function over form for today it is. However, as it seems, I always get a low timeout error in BASIC. So something is still not 100% right here. And here comes the big time. Aha! How on earth is the computer supposed to pick up the data if I have a playback on the loudspeaker of the cassette player? See the side panel connector, where I have the two 3.5mm plugged hooked up to both AUX and mic. Well, that's wrong, as both AUX and mic are for line recording. But I need to feed one signal back into the PC, so the correct plug for the secondary attachment would be the ear connector, of course. Let's give it another shot with the correct plug being connected to. Listen carefully for the relay once I press enter. See how the cassette starts to play automatically. Here's the relay for the motor control again in slow motion. And I still get device timeouts in BASIC after all. Something is still not right here. I wired up my oscilloscope to the data in wire on the DIN connector side to see if I can measure anything during playback. But there was not really a signal. Did I mix up data in and data out after all? Okay, it's the other way around. I mixed up the wires. See the wave curve we get now on the data inside. So now that I have fixed my own mistakes, I'd expect BASIC to finally load the diagnostics utility from tape. This is now how it should be done. After a staggering loading time of 4 minutes, we're finally presented with the Advanced Diagnostics menu. The diagnostic provides various test routines for the various system components. From here you can test the mainboard and the memory, the disk controller and of course the graphics adapter. The latter provides ample of options for various tests for text and graphic modes, character sets and different display resolutions. After all, it's quite archaic, but it does the job, and I'm happy to see that my homebrew diagnostic cassette actually works. In the meantime, I have added the floppy disk controller back and attached the primary floppy drive to it. But I'm definitely missing here something as well, as the floppy disk drive does not perform the initial drive seek sequence and the PC starts directly into ROM BASIC. Once again, I had to consult the IBM PC documentation to better understand this. And I found that the primary floppy drive in the 5150 need an active line terminator in place. That's this blue thing that looks like an IC with the label reading TRS. I have two identical tandem floppy drives, one that came along with this machine and one that I bought off eBay. Now guess which one I hooked up. Right, exactly the one without this terminator in place. I swapped the drives and now it performs the drive seek sequence and also boots off the floppy drive as expected. And what's better than one floppy drive? Right, two floppy drives. But here again I seem to have been missing something. Even with the second drive being connected and a floppy inserted, whenever I try accessing drive B, the system would access the disk in a primary floppy drive A. But then I remembered again, how could this machine possibly know what I'm up to? In other words, how would it know that I had connected a second floppy drive? The BIOS settings it is. It's only that this machine uses dip switches. There's two dip switches blocks on the mainboard, whereas SW1, which is the bottom one in this picture, is of interest. See how positions 7 and 8 are both set to on? This tells the system it has one floppy drive installed. In order to configure the system for two floppy drives, I have to set the switch position 7 to off, while switch position 8 remains on. So after flipping this into the correct position and one power cycle later, accessing drive B now actually works as expected. And this shows perfectly what long way we have come in the past 40 years. Nowadays, it mostly works plug and play, and you really don't have to care for dip switches or jumpers to be set at all. The IBM 5150 demonstrates very well how archaic the good old times were. Not only did I manage to sort the vertical sync issue with the 5153 CGA display, but also successfully replaced the tantalum capacitors of the mainboard to make it work again. I'm totally happy how this worked out to bring the machine back to life. I'm also happy how it turned out with the cassette interface. Even with the temporary wiring, it was an experience worth doing. Of course, I had known data sets from my C64 back in the day, but getting this to work on the IBM 5150 was really satisfying. Time consuming, yes, but satisfying. But wait, I'm not done yet with the restoration. Next time I'll turn to the reassembly. Plus I have to look again at the Model F keyboard for the non-working keys. And as you may have noticed, this machine is lacking serial RS-232 and parallel port interfaces. I managed to find not only these, but also a proper DIN cassette cable. There's definitely more shenanigans to come. I hope you liked this video. If you did, then please give me a thumbs up. See you next time.